we will solve this today's LeetCode problem. This is sum of left leaves. This is a LeetCode easy problem. Here, given the root of a binary tree, we need to return the sum of all left leaves and a leaf node. So what is a leaf node? Which has no children, right? That is 9, 15, 7. These are all leaf nodes because this is at last and this has no any children. So we need to find a sum of all left leaves. So left leaf is what is? It is left child of another node. What does it mean? That if any node has a left leaf, left child, and it is a leaf node, then we need to return its sum. Just if we see, this 3 has left child 9, and this is also leaf node, so we will consider this 9. For this 20, 15 and 7 is a leaf node, but 7 is at right and 15 is at left, so we will consider this 15, not this 7, right? So what will the summation? 9 plus 15, which is equals to 24, right? Okay, so if you have seen, this root 1 is already given 0. If there is only one node, then we will consider it as a 0 because it is neither left leaf node, it is neither left leaf nor right leaf, right? So it is a given 0. So we have given 1000 and this is given 1000, right? So what we will do, can do, so we can use two part, right? One is a recursive approach and other one is iterative approach, right? So this is something like, this is DFS and this is BFS, which is Q, right? So let's discuss this recursive approach first, right? So in this recursive approach, what we will do, in this recursive approach, what can I do? I will move to its root and move its left and right part, right? And whenever I get a leaf node, I will insert it in my vector. But here is a catch, that I will insert only that leaf in my answer, or take as my answer on vector or sum, which is at left. So for that, can I uh, can I make a check variable, that if check variable like a check variable like if my left if I move to root left, then I will mark this check as a 1. If I move left, I will mark this as a if I move left and check is 0. If I move right of no, right? So that I will take consider only that leaf node which is at which marked as check as 1, right? Right. So what does that mean? Suppose I have gone 3. Let's take this example. This is 3. This is 3. This is 9. Again, this is 20. This is 20. Right. This is 20. This is 15. This is 15. And what is this? This is 7. Right? This is 7. So if you see in this case, we will move to first 3, then we will move its left part and then right part. So suppose here in this case, here this is 3 and 0, and when I move to this part, I will mark it as what I will mark? I will mark this as 1 because I am moving 1, because it's a left part, I will mark this function as a 1, and I will move to its root left part, right? I think you understood part, because it's hard enough to visualize this here. It's very hard actually. So uh, this is 20 and this is it. Just one example I will take here. In this case, for this case, this is 15 and 7, right? Again, yeah. So this is root left, and I will mark this as 0 when I move its root right, right? So if this 9 is leaf node, so I will consider in my answer, which is summation, I will consider this in my answer, right? What I will consider x. So now this will return me 9, this will 0, right? So this is 20. So this is not a leaf node. I will again move in this part, right? This 1 and root left, and this again 1 root right. So this is also a leaf node, but it is marked as 0, so we will not consider this. We will consider this 15. So this will be 15. So here this is the we will consider this as a recursive approach, right? So what we can do is I will just take, if this root is null, I will return 0, right? Or what? Or if it's root left, or we can return 0, and then I will move to its solve function. Now I will check for this root value, right? So what will I check? I will move it to its root ka left and root ka right, right? So if its root left and its root right is this, then I will return 0. Otherwise, what I can return, I will return this solve function, solve root ka left So this will be the solve function here, this will be the root. Now I will mark as a check, which is equals to 0 for now, right? So if this will be taken as void, or I can take as an end also. So end solve end tree node end check for left, right? So here this is root ka left, which I have written. If root left and root right is leaf node, and if root left and root right is leaf node, and this check variable, and this check is also 1, right? Then if this this should be checked, that this check is, what is this check, right? So in this case, if check is a leaf node, then I will return root, otherwise I will return 0. I will return 0, or you can write as check, because I am just returning this. So this should be bool value, because I am just checking it. Now I will move to its root left part, and I will mark this as 1, and also I will move to its root right part and mark it as 0, right? And I will return summation, right? And I think that's worked. Let's try run this. So I have on 3, I marked as 0, I move to the 9, with 1. So 9 is at here, this is leaf node, this check is marked as 1. I will return root. Okay, this should be root value, right? So it will mark as return value, and when it comes to 20 root right, it will be marked as 0. Now this root 20 is not a leaf node, it will come to 15, it has root left which is 1, so which is 15 will be taken, and this will be 0, right? I think this will work. Let's run this. Okay, this should be checked for left. Let's run. Yeah, let's submit it. For this 1 2, this 1 is at left part, so when I move to its okay, sorry, I need to check whether its right part is still exist or not. So I just need to return if this is the root, this is return 0. Yeah, I think that should work. I have missed this test case. Let's submit it, because it's possible that root does not exist. Yeah, we have passed the test case. So for this DFS part, if I remove this, so now I will, so this what will the time complexity will be this. So we need to iterate in whole tree, so that will be O of number of nodes in the tree. So the time complexity will be O of n, where n is number of nodes in tree, and there is also a recursion stack which will be also O of n due to recursion stack, right? And the space complexity will be we have not taken any extra space, so that will be O of n. So how we will remove this O of n extra recursion stack, right? This, how can I remove this recursion stack? So that will the approach of for the iterative approach, which is BFS, right? So for removing this, what I can do is I need to take a queue and that will increase my space complexity for that. So what I can do is I will take a queue, and what was I doing in my recursion? I was taking a check for left and marking a root. So same thing I will do there. I will take a pair and take it as a bool. I will mark as a bool, and this is queue. So if okay, I need to first check whether this root exists still or not, and this will be written 0, right? Now I will push q with root 0, root ka value 0. Okay, root, not root ka value, this should be tree node, and this will take as a summation variable. So I will take as a queue, and the same thing I will do. I will iterate in this queue. Okay, so first will be the node, and the second will be the check. This will be the q dot top, sorry, q dot front, and this will be q dot pop. So I will check the first value, and I will check whether this node left exists. If it is exist, I will insert it in my queue with what? With 0, 1, sorry. And the same thing goes with here for right. If my right exists, I will insert this in right. Now for the summation value, what will I do? I need to make a check for that, right? If what will I check? whether this is if this node left and this node right, and this is check, then I will insert my node value in my summation, otherwise I will leave it and I will return answer. Understood? So what I've done, I've done these things in my iterative way. I will insert root with 0, and if I move to its left I will insert 1. If either I will register 0, and I need to check whenever I pop out that whether it's leaf or not. If it's leaf, then I will check for the left part and I will sum the node value and return answer. So yeah, let's see. Okay, I have done summation, not answer, and I need to return the summation. Yeah, I have passed the case. Let's submit it. Bingo, we have passed all the test cases. So what will the time velocity for this iterative way? So that will be O of n only, because we are iterating only the number of nodes of element, and we have successfully removed the recursion stack space time velocity, but we have used an extra space which is Q data structure, and that will be roughly O of n. If you want to take that, then it will be O of n. Otherwise it will approximately it is not O of n, it is only the number of maximum rows in at a height level, right? If you observe, it is only taking the number of nodes which are at height of some level, right? So that will be take off. So this is an iterative approach using Q. So I think you must have understand. Thank you.